All right, today what we are going to do is a proof by contradiction. So let's write that out. Contradiction. Now this is a pretty cool proof technique. I think if I had to choose a favorite, this might be my favorite. If not this, then combinatorial proofs, but we're not talking about those. We're talking about contradiction. So, what is a proof by contradiction? Well, when we're given a statement, right, we're given our premises and then our conclusion, right? And we want to determine if that conclusion is true or false. And so we always assume our premises are true if we're doing like a direct proof, and then we logically argue to our conclusion. And then once we reach the conclusion, we're like, look, we got here logically, which means it must hold when the premises hold. For contradiction, right? What we're going to do, right? We're going to assume our premises are true as normal, right? Like with the direct proof. Assume our premises are true. Assume our premises are true. Now, what we're going to do is suppose the conclusion is false, right? So we're going to suppose the conclusion is false. Next, what we're going to do is argue to a contradiction. So we're going to logically argue to a contradiction. And then once we reach that contradiction, we argue to a contradiction, and then what we're going to do is now our supposition must be false. Our supposition must be false. So the conclusion must be true. Must be true. And let's think about why that would work for a second, right? Let's think about a real life argument, perhaps, where you argue towards contradiction, right? Say you're arguing with a friend, right? Maybe a friend is lying to you. Maybe a friend is claiming that they did something that you know that they didn't do, right? But you know that what they're saying is false, right? So your friend is like, oh, I didn't go to the store, right? But you know that they did go to the store, right? So let's suppose that your conclusion is false, right? Suppose my friend actually did to go to the store. Well, then that would mean blah blah blah. And then that means blah blah blah. And then that means blah blah blah. But that contradicts blah blah blah. So that means that you could not have gone to the store or whatever I said was the lie, right? So that's kind of the basic gist of a contradiction. You assume something to be false, and you're like, okay, let's see what happens if that's the case, right? But you reach a contradiction, so you're like, okay, well, that could not have been false, which means it was true. Hopefully that kind of makes sense. We're going to go through an example right now, right? So here's what I'm going to do, right? I'm going to claim something. So claim. Um, there does not exist an integer. There does not exist an integer that is both even and odd. And clearly that's the case, right? An integer is either even or odd, right? It can't be both. Um, Worded differently, this could say, if x is an integer, then x is even or odd, right? So let's actually write that down, right? So let's say if x is an integer, then x is even or odd. So, for a proof by contradiction, and that's what we're going to do to prove this, how do we do that? Well, let's look at our like outline that we did right at the beginning. So, proof. We're going to assume our premises to be true. Okay, so let x be an integer, right? Suppose the conclusion is false. Okay, so x being an integer is our premises, right? X is an integer, and our conclusion, x is even or odd, we're going to assume that to be false. So we're going to say x is even and odd, okay? So we'll say suppose for the sake of contradiction. And it's important when you're doing a proof by contradiction that you state that right at the beginning. So that way your reader, your grader knows exactly what kind of proof technique you're doing. So suppose for the sake of contradiction that x is even and odd. Let's see, x is even and odd. So then there exist integers a and b, right, such that x is equal to 2a, because that's our definition of an even number, and x is equal to 2b plus 1, because that's our definition of an odd number, right? Okay, then we'll say, so if x is equal to 2a and x is equal to 2b plus 1, then 2a is equal to 2b plus 1, right? So then 2a is equal to 2b plus 1. And I'll say, which implies, let's see, what do we want to say that this implies? A is equal to b plus 1/2. And then I'll say, which implies a minus b is equal to 1/2. And I'll say, however, the difference between two integers, is an integer. But 1/2 is not an integer. It's not in the set of integers. So this is our contradiction. And when we reach our contradiction, we usually indicate it with a symbol. People use different symbols. I think the most common one you'll see are two arrows pointing towards each other. That's what I always do. So you say, however, the difference between two integers is an integer. Okay, let's go back and look at our contradiction formula, right? So we said argue to a contradiction. We did that. Our supposition must be false, so the conclusion must be true. Okay, so we suppose that x is even and odd. Okay, so we reached an integer. We reached a contradiction, so we say, thus, our supposition must be false. Must be false. And remember, our supposition was that x is even and odd. So it must be the case that if x is an integer, x is even or odd. And for extra emphasis, I'll just say x is even or odd, but not both. And that is our proof, right? And this is a simple statement to prove, right? There does not exist an integer that is both even and odd. We obviously know that's true. That's why I chose this, because it's easy to demonstrate with a proof by contradiction, right? So I hope that made some sense to you. I think contradiction is another just really strong tool in like our toolbox, and that's what we're doing with learning all these different proof techniques, is filling up our like toolbox so that we have all these different things at our disposal to use when we have a statement. So if you made it to the end of this video, thank you for watching. I really appreciate it, and I hope you learned something.